Alright, so once again, welcome back to another exciting day of mathematics. Whoop, whoop. How's everybody doing? Good? Friday? Yeah? Let's go. So warm-up number 27 reads for numbers 1, A, and B. It says simplify to lowest terms. Factor each number first. Part A is 4/20. Part B is x squared plus 5x plus 6 over x squared minus 3x minus 10. Numbers 2 and 3, it says to factor. Number 2 reads x squared minus 3x minus 18. And number 3 is 2x squared minus 32. Number 4, it says solve for y, then evaluate when the domain is -3, 0, and 3. And the equation given is 3y minus x equals 4. And number 5, add or subtract 8 over 18 plus 5/6. Alright, copy that and I'll give you some time. Ready and go. Alright, let's see what we got. Number 1A. 1A, Mr. Q. Alright, I got this. And then I can pick someone. Woo. For number 1. Should have gotten 1/5, yes? And how to get there? GCF for these two is 4 times 1, 4 times 5. Identify the giant 1, and there you go. Okay? 1B. Let's see. Someone was raising their hand from back there. Was it Caesar? What did you get for 1B? What is it? 3 over -5. Close. Isaiah. Hands if you got that. That is correct. So factor this one. 6 and 5. It's 2 times 3, yes? So my factor are x plus 2, x plus 3, over, we got 10, -10, -3. What factors of -10 add up to -3? -5 and 2, yes? So x minus 5, x plus 2, giant 1, and that leaves us with that. Alright, good. That tells me we're ready for a pop party, right? Yes? Here? Because we have addition and subtraction. Yeah, remember guys that we can only identify giant ones if there is multiplication. I did it with numbers, and then we did it here. Since the parentheses are multiplication, it's multiplication only. Okay? Alright. Number 2. Alejandro. X plus 3. X minus 6. Hands if you got that. Alright, pass to someone. Hector. First, what's GCF? 2, and you're left with x squared minus 16. And what is this? Close. X plus 4, x minus 4, and the GCF. Hands if you got that. Okay, good. Number 4, pass someone. Andres, y equals what? Yeah, well, trust your instinct. If there's a coefficient on x, what would go in front of the x, including that 3? So you're stuck with a division part. So imagine there's a 1 in front of the x with that 3. What would you write in front of the x? What is it? A 1 over what? Alright, let's see. So we add x. 3y equals x plus 4. Yes? And then divide by 3, divide by 3. So we're left with 1/3 x plus 4/3. Yes? Is that good or? Okay. And you can do this last one in decimal form, 1.3 repeating, but I'm going to leave it as a fraction. So, domain, -3, 0, 3. Alright, let's see, help me with this one. Shane, if I substitute -3 in here, what is -3 times 1/3? Who's got it? 3 times 1/3? Gavin? -1. 3 times 1/3 is 1, but it's a negative, so it's -1. So then this is 1.3 plus -1, and that leaves us with 1/3 or 0.3, yes? Next, 0. Yada yada, so what do we get, Areli? 1 and 1/3, so 1.3 bar, okay. Pass someone, Areli? Oh. Chantal, what'd you get for 3? 3 times 1/3 is? 1 plus 1.3, that is 2.3 repeat. Okay? Alright, and number 5. Jasmine, what'd you get for number 5? What is it? 23? Over what? Let's go. Hands if you got that. Let's go. And I'll leave it like that for right now. Alright. So, agenda for today, here we go. Warm-up number 27, no pop party. I know, you're disappointed, I know. So we're going to do extra practice today. We're going to do more practice on addition. I know that we need to see different other ways, and I know you love addition of rational expressions. And today I'm giving you play sheet Q, and it's an extra practice play sheet. Now, pay attention to this part. For tonight's home play, I included the answers. What does that mean? So you can check your work. So I want you to work it out, and if you don't get that answer, guess what? You made a mistake. So try to figure out what the mistake was. Please, please. And no, don't go to those apps that are going to give you the process. Try and do that on your own. My goodness. That was all, that's last year's stuff. Come on, no cheating anymore. Alright? So here's your, for those of you watching online, here's your Nearpod code, LNEHF. And in there is a PDF play sheet for tonight's home play. And also the final slides that we're going to go and review in a little bit. For those of you here, you can find the play sheet in here or on Canvas. It's on Canvas as well. Alright, and last night's home play, get that out. Please take a picture, submit on Canvas. But I do want you to pick one of the problems that gave you problems. Bam, and talk it over with your neighbor and see what they got. Hopefully they figure that one out. If not, help them out. I'll give you some time. All right. So Get a Cornell note ready. We are going to continue today's objective. Once again, I can add and subtract rational expressions, but as I explained, we're focusing just on addition right now. Okay? We don't need a fair, or you know what? We do need a fair model. How about that? Oh yeah. Without looking at your notes, fill out your FAIR model, definition, one example, one unexample, and a hashtag. What are rational expressions? So if you want to do the definition in your own words, that's fine. Rational expressions, what are they? One example, one non-example, one hashtag. Once again, those of you that are watching online, if you are absent and you're watching this video, make sure you turn in your home plate on Canvas. And, yeah, we'll go from there.
Yes, Mr. Q.
All right, good. All right, share your definition with your neighbor without looking at your notes. What was your definition? Oh, really? Fractions. Yeah, fractions, but with what else? Polynomials. Come on, people. In your own words, fractions with polynomials. And then put on fire or whatever, you know? Yeah. All right, so this is what it looks like. Yes, something like that? All right, and then I gave you guys a formal introduction to the definition of rationals, which is Q equals such that fractions of m over n, where m and n are integers, but the denominator cannot be 0. We call that the excluded value, yes? And then I gave you guys the process to follow. Fairly simple process. Step 1, to factor the denominators first and figure out what each denominator is missing to have a common denominator. Whatever that's missing, you multiply times the numerator. You bring down the numerators, the original ones down, and then you go to rewrite. That's step 2. Rewrite as one fraction. Focus on the numerator, multiply whatever needs to multiply it, then combine stuff. From there, you simplify by identifying giant ones, but if you notice on the home plate, the numerator needed to be factored once more, pretty much most of the time, yes? And then from the identify giant ones, and at the end, your excluded values. So yesterday we did something like this, this, and this, and this, and this, and this, yes? All right. So for the sake of time, I'm going to go ahead and do some problems from the home plate. So get your home plate in front of you and get a blank sheet or there in your Cornell notes, you're going to copy the problem that we're going to work out together so you can see the process, yes?
Yes, Mr. Q.
All right.
Thank you, Mr. Q.
You're welcome. All right, let's see. Polynomials. No, not polynomials. Let's go to rational expressions. And adding rationals, right? Okay. All right. So let me start. Of course, not number 1, right? Not number 2. Okay. Not number 3. Okay. How about number 4? All right, let's go over number 4. Copy this one, please. Let me zoom in. There it is. We got b over 4b plus 7 plus 7 over 16b plus 28. That's 4, right? On your home plate? Yeah, okay. All right, so let's see. I'm just going to abbreviate. Step 1 is to factor, yes? Okay. So I'm going to factor the denominator. Can I factor this anymore? No, so it's 4b plus 7. Can I factor this one? Well, not with Power Rangers, but I can check for GCF. What's GCF? 4, and we're left with 4b plus 7. Now, for those of you that are struggling factoring this, you think of a number that divides both numbers. Start with 1, yes, 2, yes, 3, no, 4, yes, and then from there you write the 4, and then start 16 divided by 4 is 4, 28 divided by 4 is 7. All right. So, now that we factored both denominators, we've shown step 1, we need to identify the common denominator. Now, do both of them look identical? No. That's how we identify a common denominator. What is this one missing from over here? Nothing. What is this one missing from over here? So that means we need to multiply times 4. And I want you to pay attention to the word. We multiply times a certain number to make it common. We do not add, we do not subtract. Once again, to get a common denominator, we do what? Multiply. Tell you what I just said, please. Yeah, so whatever we do to the denominator, we do to the numerator, and the numerators, the original ones, we bring them down as they are. So we got b, and we got 7. So we're done with step 1. Step 2, that's when we add. How do we add? By rewriting this as one fraction. Okay, well, let's see. What's my common denominator? 4 times 4b plus 7. And now we focus on the numerator. However, can we multiply stuff here? Yes. What is 4 times b? 4b. So now I'm going to use the 4b instead of using that, because I already multiplied it, right? So let's see. What is 4b plus 7? Can we combine those? No. We just write them out. So we end up with 4b plus 7. Now, in class, I told you guys whenever you end up with something like this, we need to get GCF of 1 in order to identify the next step, which is the giant 1. So I'm going to put step 3, giant 1. Giant 1. So how do I do that? Well, before I do that, I need to factor out here. There is no other factor but 1. So I'm going to write 1 times 4b plus 7. And why do we do that? So like your noodle can actually identify it. Now is it easy to see, is that correct?
Yes, Mr. Q.
So there's a giant 1, and we end up with 1/4. And that's already simplified. And have you got that by yourself? Okay, good. Now, the extra step that I add is excluded value. Is that correct? EV. So how do we get the excluded value? At the end, when you're done, you get that denominator and set it equal to 0. So we got 4 equal to 0. However, we need to solve. Read it. Is that true, what we just have in front of us? No. And what does that mean? That there is no excluded value. So simple, right? All right, so once again, I'm asking you to do a GCF here of 1. However, look up, if this was a negative, then the GCF would be what? -1. So make sure you extract a negative if the first term is negative. All right, let's move on. Oh, sorry. Where were we? 4. Somebody said 5, right? Okay, copy this one, please. 8 over x plus 4 plus 3 over x minus 4. All right, once again, I'm going to start with step 1, and we have to do what? Factor. Okay, I'm going to do that in green. Can I factor the first denominator more? No, so I just bring it down, x plus 4. Can I factor the second denominator more? No, so I just bring it down, x minus 4. All right. Are they identical? No, you're like, Mr. Q, but it's only a little line that I can just do. No. We need to multiply times something to make them look alike. So, question. Can I multiply this times a negative to make it look like that? No, because then this is going to turn negative. So what do we do, Mr. Q? Well, this, let me give you an example on the side of what that is implying. Check this out. Have you ever encountered something like this? 1/3 plus 2/5. What do you do to get a common denominator? Tell your neighbor for that one. What do you do? You multiply the 3 times 5, is that correct? Yes. All right, so guess what? We do the same thing here. So here we multiply x times 4, x plus 4 times times x minus 4. Top and bottom. And now we ask the question, what does this denominator need to make it look like this denominator? X minus 4, yes, x minus 4. We do the numerator as well. Does that make sense? I mean, make sure you make a note of yourself on the side with this. So in order to get the common denominator is 15 by multiplying the denominators. Put a little big dot so you remember to do that with these kind. Okay? Now that we have that, just bring the original numerators down. We got 8 and we got 3. So we're done with step 1. Let's go to step 2. What do? We're going to add, Mr. Q. And how do we add? Well, we need to rewrite this as one fraction. So, hold on, let me move this out of the way. There it is, okay? So, what is my common denominator? X minus 4, x plus 4. Next, focus on the numerator. Leave space above here, because we need to distribute, right? Yes, Mr. Q. All right. So let's start with this one. What is 8 times x? 8x. What is 8 times negative 4? Negative 32. Okay. How about here? 3 times x is 3x, and 3 times 4, that's 12. And now we can do what? Add. Let's combine stuff. What is 8x and 3x? 11x. What is negative 32 plus 12? Negative 20. All right? So, what did I say when we have something like this that doesn't have a GCF? Extract a 1. So we got GCF of 1, parentheses, 11x minus 20. And this is just to check to see if we can actually have a giant 1. X minus 4, x plus 4. Okay? All right, look at it. Do we have a giant 1? No, so guess what? We are done. This is our sum, or our simplified of the addition. All right, so step 3 was the giant 1, which we didn't have any, and at the end we do what? Excluded values. So you never what to write for the excluded value. What do I write for the excluded value? Yeah, since we have two factors, you write x minus 4 equal to 0 and x plus 4 equal to 0. So the denominator equal to 0, and then you solve. Plus 4 plus 4, x equals 4. minus 4 minus 4, x equals negative 4. Are we done? Yes? Okay. Yes. All right, let's move on. Is that clarifying? Yeah? All right. This is number 6. Do we need to do number 6? Yes? Copy this one, please. 3x over 2x minus 3 plus 3x plus 6 over 2x squared minus x, plus x minus 6. All right, let's start with step 1 again, which is what? Factor. Okay, can we factor the first denominator? No, so it stays the same. 2x minus 3. Can we factor the second denominator? Yeah. So, what is 2 times negative 6? That's negative 12. What is the coefficient here of the middle term? 1. So what two numbers multiply to give me, first let's think about the two numbers. What two numbers multiply to give me 12? There's only 1 times 12, 2 times 6, and 3 times 4. Which one of those, if you add or subtract, give us 1? 3 and 4. So 3 and 4, one of them has to be a negative. The 3, the smallest one, because this has to be positive, that means the biggest one is a positive. All right, now check this out. Some of you made a mistake last night by writing your factor x minus 3, x plus 4. What did I say when we first started this? That you can only do that whenever you don't have a coefficient. So what do you do then, Mr. Q, when we need to rewrite this? What's my first term? 2x squared. And then instead of 1x, instead of the 1x, I'm going to write negative 3x plus 4x. You guys remember these, yes? What's my last term? My last term is negative 6. Let's group. GCF here is x. We're left with 2x minus 3 plus GCF here is 2, and we're left with 2x minus 3. So what's the same here and here? 2x minus 3, and that goes down here in the denominator now. And what's left for the other factor? X plus 2. Alright. So we're still on step 1. We need to now make it a common denominator. So what do I need to do to the first denominator? Multiply times x plus 2. So x plus 2. And whatever we do to the denominator, we do to the numerator. Let's bring down the original numerator. The originals are 3x and 3x plus 6. They'll stay the same. And I hope you're getting the idea. When we did the practice on the warm-ups, I always brought the numerators exactly the same. Did anybody remember that? Exactly the same. That's what happens here as well. Okay? All right, step 1 is done. Let's go to step 2, which is to add. Okay? So let's add. That means we make it into one fraction. We got x plus 2 and 2x minus 3. Now look up. Does the order matter? No, in multiplication the order doesn't matter. That's what we call closure in multiplication. Alright, so then now we focus on the numerator. Can we multiply anything over here? Yeah, distribute. What is 3x times x? 3x squared. What is 3x times 2? 6x, okay. Do we do anything over here? No, there's nothing to multiply. So now let's combine these with this because we are adding, yes? All right. So 3x squared, I can't combine in anything, so I write 3x squared, okay? Then I got 6x plus 3x, that gives me 9x, and then at the end, plus 6. Whew, yeah, I like this one. Alright, look at it. Are there any giant ones? We can't, Mr. Q, we need to factor this one. So your brain is trying to tell you what to do here. GCF is 3, that leaves us with x squared plus 3x plus 2. Bring this over, x plus 2, x, 2x minus 3. Alright, let me make some, I'm going to continue down here, okay? So I'm going to rewrite it here so that I can continue. X squared plus 3x plus 2. And the GCF was 3. And then I got x plus 2, 2x minus 3. Okay. Next, can we factor this? What do I do? 2 and 3. What two numbers multiply to give me 2, then when you add them give us 3? 1 and 2. Now, does this one have a coefficient, the one inside of the parentheses? No, so we can do the shortcut, yes? So 3x plus 1, x plus 2, over x plus 2, and 2x minus 3. Do you see the giant 1 now? Yeah, that's step 3. Giant 1. Okay, so my giant 1 is x plus 2, x plus 2. And why am I allowed to do that giant 1 sideways? Because there's multiplication here, and here, and here. Okay, and what does that leave us with? We got 3 parentheses x plus 1 over 2x plus, minus 3. 2x minus 3. And we're done. Alright, tell your neighbor what to write for the excluded value. Excluded value. Sis, are you good? Yeah? Okay. Let me see, help us out, Andrea. What do I write for the excluded value? Let's go. So plus 3 plus 3. Remember, always take the denominator and do that. 2x equals 3. Divide by 2, divide by 2. X equals 1.5. This one's pretty good, right? Pretty good, yeah? All right. All right, let's see what else we have in here. Let's see. Is this number 7? Okay, do I need to go over number 7? All right, let's go over number 7. Copy this one, please. 3 over n plus 1 squared plus n over n squared minus 1. This is a cool one, by the way. I was like, oh, snap. You're probably like, yeah, Mr. Q, because you're crazy. When was it? I think 2 days ago, my wife was trying to wake me up from my sleep. I don't know. I think our dog needed to go outside. And in between, when I answered her, I said, listen. And I was about to give her a polynomial. She was waking me up. She said, listen, what is this? Listen, Linda? Remember that little kid? Listen, Linda, listen. Never mind. Anyway, here we go. Step 1. Factor the denominators. All right, this is going to be an easy one. So how do we write this in factored form if it's to the second power? Tell your neighbor, how would we write this in factored form? Yeah, n plus 1 times n plus 1. You're like, what? I know, right? Okay. Next, look at this one. How do we write this one in factored form if it's a difference of squares? Everyone? N plus 1 and n minus 1. Okay. So, start here. What does this one need that this one has extra? N plus 1, yes, and we do that to the numerator as well. Right? Because this is 2 of them, this one needs 2 of them. Now looking at the denominators, what does this one need that this one has? N minus 1. And we do that to the numerator as well. Alright, let's bring down the original numerators. Here we go. We got 3 and we got n. So we're done with step 1. Let's go to step 2. What is step 2? We need to add or write it as one fraction, yes? Alright, so my denominator, I'm going to write, starting here, I got n minus 1, n plus 1, and n plus 1. Okay. So, let's focus on the numerators. So what do we do here? Distribute, that leaves us with 3n minus 3, yes. How about over here? Distribute, that's n squared plus n, yes. And now we're going to add. Combine whatever you can, but let's write it in standard form. Tell me what you write, Davin. Let's go. We're kind of like, yeah, we're good? All right, what do we do next, people? Factor, negative 3 and 4. What two numbers multiply give me negative 3 that when you add them give us positive 4? So if there is none, what can we conclude? We are done. Let's go. Remember what I told you in class? If you get stuck so much that there's nothing that you can do from there, just stop right there and finish. Alright, but we still need to find our what? Excluded values. Now be careful with this one. In order for you not to do extra work, tell your neighbor what to write to get started with our excluded value. I heard n minus 1 equals 0, which is this one, yes. What else? N plus 1 equals 0, which is this one. Do I need to write it again? No, because I'm going to get the same answer. So let's just solve here. Plus 1 plus 1, n equals 1. Minus 1 minus 1, n equals negative 1. This was good, right? Good one, yeah? Alright, let's see what else we got. This is easy, right? Yeah, difference of squares, it's the same for both, yes? Okay. How about this one? Let's do this one, yeah? Alright, let me zoom out of this one. Alright, so copy this. Don't copy the words, copy this. Remember that I told you to draw pictures, yes? Okay, good. So this is number 9. Because I'm giving you another one of these. Yay! Oh, yes. Alright, it says the length of the rectangle is this. Alright, so let me label that. The length, 4 over y minus 4, 4 over y minus 4. Okay? The width is that. So 2 over y, 2 over y. In meters. We'll add that at the end not to get confused with more variables on there. Alright, but then it says, what expression for the perimeter? Perimeter. So how do we find the perimeter of any figure, people? We do perimeter equals side, plus side, plus side, plus side. As many sides as the figure has, right? So I'm going to start slow, and I'm going to use first two sides, yes? So I'm going to start with these. So I'm going to write 4 over y minus 4 and 4 over y minus 4. You guys see that? I did this and that. Since they are common denominator, tell your neighbor what is the sum of these two fractions. Yeah, 8 over y minus 4. That is correct. You guys see it? Same denominator. 4 plus 4 is 8. Okay. Plus, now let's go with the other two. 2 over y plus 2 over y. Now tell your neighbor the sum for those two. 4 over y. Yes. All right. But now we have a dilemma. We need to add these two. Let me zoom in. Can I subtract a 4 here so that it can look like that? No. What did we say for denominators? We cannot add or subtract. We need to do what? Multiply. That means this side, I'm going to multiply times y minus 4 times y minus 4. Therefore, what's our common denominator? Oh, sorry. This needs a what? A y. Sorry. Okay, now we have a common denominator. Y minus 4. And then we focus on the numerators. Multiply, this is 8y, yes. Distribute, that's 4y minus 16. Combine, what does that give us? 12y minus 16. Can I factor this more? Yeah, GCF is 4. That leaves us with 3y minus 4 over y and y minus 4. Can we do anything else from there? No. Good one, guys. Enjoy your home play. See you guys till Monday. Bye. Hope that helped. Yeah?